Hello everyone, I hope you all are doing safe and sound. Welcome to my channel DevOps Tech Stack.
Hi all, welcome to the day 6 of the Kubernetes series. So here today we are going to discuss about the Kubernetes controllers. This we already discussed in our previous lectures, but today specifically we will talk about the replication controller and the replica set. So it basically ensures that your application is available and there is minimum downtime. So that's how your replica set or replication controller comes into the pictures. It is basically behind all the operations. This is the brain which is functioning. Okay. All the decisions are being taken by the controller. There are multiple types of controllers available in the Kubernetes. So now we will talk about the replication controller. Okay. Now, controllers are the core concept of the Kubernetes processes. All the decisions, everything are being taken care by the controllers itself. They basically monitor the state of your Kubernetes object. Basically, if you have deployed pod, replica set, stateful set, anything if you have deployed onto your Kubernetes cluster, it will monitor the state of that particular object, that whether it is in the desired state or not. If it is not in the desired state, it will make sure that your application will again come back to the desired state. Let's say if you have one application for say example Python application. Okay, so that Python application is running in a single pod, and if that pod goes down, then your entire application went down, right? But here only replication controller comes into picture. It makes sure that that particular pod should be recreated until and unless there is some configuration issue. Again, it will fail, but it will try to recreate that particular pod again and again. Okay. So here I am showing the same example. This is my node. On this node, I have one pod deployed where my application is running. Let's say if this pod dies, then replication controller, which is running on the master node, it will make sure that the pod is recreated again within a few seconds. Okay. Let's say the pod dies, replication controller will make sure the new pod is getting recreated. Replication controller is basically monitoring your pod. So behind the scene, replication controller is monitoring all your Kubernetes object and trying to maintain the desired state of that particular Kubernetes object. Okay. Now, even if there is a single pod on which your application is running, which doesn't happen in your production clusters, there are multiple pods where your applications are running. But even if it is a single pod failure, in that case also your application will go down, right? So in that case also your application controller will try to recreate that pod again and again till the time the issue is not fixed. Okay. Now, what is the replication controller? What is its main purpose? So it is trying to maintain a high availability in your environment, right? It is trying to maintain that your application doesn't go down and user should not face any trouble because of these situations, right? Replication controller ensures that multiple replicas of your pods are running. Let's say if you have two nodes, on the two nodes pods are running, means it is serving the multiple instances of your application. Here also one instance of my application, here second, then third, then fourth. Like that way, on the multiple nodes, the pods are running, right? And the traffic is being managed, that is a different topic, that how the load balancing and scaling are happening. But behind the scene, user is getting response through these particular pods which are running on multiple nodes. If one pod fails, the replication controller automatically creates a replacement. So in my case, if it is a Python application, I have set the 4 replica because 4 pods are running on which our applications are being served, right? So if one pod goes down, let's say this pod goes down, then again it will try to recreate that pod on the same node. And if there is some memory issue on that particular node, then in that case, it will try to create the pod on the other node. But it will keep trying. That is the main agenda of your application control. It try to maintain the desired state of your pods at all times. Let's say if you have created with the 4 replica, then it will make sure that your 4 pods are up and running. Okay. If one pod fails, the load balancer shifts traffic to the others. There is the concept of load balancer, which we are going to talk later. So if the pod fails, let's say if this particular pod fails, then user will get response from the other pods which is being run on your Kubernetes cluster. I hope now it is clear, right? Even with a single pod, replication controller can be still valuable. That we already discussed, right? It automatically restarts a single pod. If it fails, it ensures that your pod is always running. It distributes the load across multiple pods. If it is running in your Kubernetes cluster, it handles the increase of the user traffic. Let's say currently you have 4 instances of your application running, but your user increased, right? Now you have multiple users, it is being increased. Now you want to serve that particular multiple users. In that case, again, you have a single command that you need to increase the replica. Now you can increase the replica from 4 to 6. And that way, your application will be in the good condition and all the users will get response, right? Now you can scale the application across multiple nodes in the cluster. This we already discussed, right? On the multiple nodes, we can have the multiple pods running, and all the pods, we can have the same application which is serving the end users, right? So now what is the difference between the replication controller versus replica set? What are these two components? They both basically serve the same purpose. They are managing your pod replica, that how many pods should run in your Kubernetes cluster for a single application, so that your end user should not face any issue because of the traffic. Okay. But replication controller is the old technology, and replica set is the latest one which we are going to talk. Okay. Nowadays, no one creates a replication controller. Everyone creates a replica set directly. So we are going to create a replica set itself. How to create that, I'm going to show you later. ReplicaSet offers more advanced feature and flexibility. So what is the main difference between these two? I will show you through one YAML file. There you can see there is one section which doesn't exist in your replication controller, but do exist in your replica set. So that's why we are going to create a replica set itself in the entire lecture. Now, this is a very important concept. What is labels and selectors? Okay, whenever you are going to create a pod, last time also we saw, right? When we created one pod, we specified some labels on that particular pod. Okay, like what is the type of that particular pod, or what is your pod specification? Anything you can mention in the label section. Label section exists. The top level is the metadata. Under the metadata, you have the label section, and in the label section, you specify the data about the pod, like what labels you want to assign on the pod. I have 3 pods, and on those 3 pods, I have assigned the labels as the app front end. The key is the app, and the value is the front end. Key is app, value is front end. Like that way, I have assigned 3 labels on my pod, right? On all the 3 pods, I have assigned the labels. Then what is the selector? So selector basically use these labels, and then it get to know which all pods I need to manage. When I will create the replica set YAML file, you will get to know it in much more detail. So labels are just assigned to the pods, and using the selector field, your object will know which all pod you need to manage. Okay. Selector uses the label app frontend, this the label which you have assigned to the pod, to manage the desired state of pods having those labels. So if you have created a replica set where you are ensuring that the 3 replicas should be up and running, then if you have given the selector as this app front end on that particular replica set, then only it will manage these pods. Otherwise, it will not monitor these particular pods. So based on this label field only, it will manage your pods. Same happens with the service object. So which all object your service should manage depends on the label assigned to your pod. That's why labels and selectors are very important concept. Labels are added to pods during creation, that we already did last time, that we have assigned labels to our pods, right? So selector in replica set use these labels to identify pods. When you will create a replica set YAML file, you will see a section called as the selector, and there you are specifying the same labels of the pod, because that replica set should manage only those pods which have the labels as app front end. This allow replica set to monitor and manage the set of pods. This will be much clear once you will create a replica set YAML file. Otherwise, this is the basic definition of the label and selector, and this is very important because it is going to play a vital role in all the Kubernetes object that we will create in the later lectures. Okay. Now let's quickly understand about the replica set YAML file. Again, there are four top level fields that we already discussed last time. API version, kind, then metadata, and then spec. These are the four major sections. The API version for the replica set is app/v1. This you can go through the official documentation of Kubernetes. There you will get to know the API version of your replica set object. Okay. Now what is the kind? The kind is replica set we are going to create. What is the metadata of my replica set? This metadata section is for your replica set itself. So replica set name is my app replica set. What are the labels on my replica set? These are the labels on the replica set, not on the pod or something else. It is on the replica set itself. So I have assigned few labels like key is app, key is type, value is my app, value is front. Then is the spec section. This is the main section where you will define your pod template. Okay. So in the spec section, since it is a replica set, I want to make sure that how much replica I am trying to give over here, right? So here I'm setting that for my application, minimum 3 pods should be up and running. So I have set the replica as 3. Now again, this section is about the replica set itself. The replica is 3. Now the replica set, in the replica set, we have set the selector field. So this replica set should manage only those pods which are having the labels app:my app. So in the selector field, you have to give the parameter that is the match labels, and the match label, the label should be same as of the pod. Whatever the labels you have assigned to the pod, the same level you have to give over here. And then there is a section template. Means for this replica set, there is a section called as template. And in this template section, you will give all the pod definition, because at the last, everything is running inside a pod, inside a container, right? So here you are going to provide the pod specification. I will show in the next slide. Okay. The replicas will specify the desired number of pods. I already told you that this field is basically ensuring that 3 instances of your application should be up and running. Adjust this value to scale your application. Means if your user is increased, you need to adjust the increase the replica. If your user is decreased, you can decrease the replica. The selector defines which pods the replica set manages. Okay. So inside this selector field, whatever the labels are assigned to the pod, you can mention over here, and only those pods this replica set will manage. Match labels is a common way to select pods based on labels. Under the select, the down level field will be the match labels, and here you have to specify the key value. The replica set can manage pods created before the replica set itself. So if the pods are already running, then it will manage them. So here it is telling, like if you have already created some pods with particular label, then also your replica set will manage those pods. Only you need to specify here the same key value or the same labels which you have in the pod which is already running. That way it will manage. So there is nothing much to worry about that. Okay. Now these are few commands. How to create a replica set. This we already created last time, right? Kubectl create -f, then the file name. How to get the replica set which you have created. Same way. How you do kubectl get pods. Same way kubectl get replica set. How to delete a replica set. Kubectl delete replica set and the replica set name which you will get from the kubectl get replica set command. If you are editing something like the replica is 4 and you have edited it to 5, then in that case you can directly replace that particular file, kubectl replace -f, then the file name. If you want to do with just one liner command, then you have command kubectl scale -replicas, then give the replica count, and then the replica set name. Like that, you can scale it with a single command. But again, this is an imperative command. This will not be useful in your projects because there you have to maintain in the Git. So through the YAML file only you need to increase or decrease the replica. That's it. Now here is a simple example where I have created a replica set. And in this replica set, I have a Redis image running. Okay. So what is happening? Again, the API version is app/v1. Kind is replica set. Metadata about the replica set is the name of my replica set is front end. The labels on my replica set is tier front end. That's it. Under the spec section, I have specified details about the replica set again. The first detail is that replica is 3. That means I have 3 instances of my Redis image up and running inside the container. Under the selector field, I will specify which all pods this particular replica set should monitor. Okay. So this label need to be same. So whatever the labels are on the pod itself. So pod definition where I am providing under the template section. Under the template, you are specifying the data about the pod. The very first is again the metadata. Metadata about what? Metadata about the pod. Okay. So whatever the pod you are going to create in this particular replica set. So the data about the pod is, again, I have assigned few labels to my pod, that is tier front end. So the whatever the labels I have assigned to my pod, the same labels should be on the replica set label selector field. Okay. Replica set selector field. It need to be same. So here I have specified for the pod tier front end, and the same thing need to be on the match label section of the replica set tier front end. Then only this replica set will manage these particular pods. Again, in the spec section, you have to specify that what is the container I am going to use. So my container is again type of list. So I have a single container running inside my pod, and the name of that particular container is PHP Redis, and the image it is using is the Redis image. That's it. Okay. I think you understood. So the main top level field is again API version, kind, metadata, a spec. These are the 4 top level. Okay. And again, inside this spec, the main section is the template where I'm specifying the pod definition, the data about the pod, the labels on the pod, and under the spec section of this particular pod definition, here you are specifying the container's name. That's it, right? So let's try to create this particular file. ReplicaSet.yaml. Okay. The very first is API version. API version is apps/v1. Okay. The next is the kind. So in kind, what I'm going to create? I'm going to create a replica set. Okay. What is the next thing? Next thing is the metadata. Data about the replica set itself. So metadata name is, replica set name is my first replica set, let's say. After that, labels on my replica set, anything it can be, app, test. Okay, key value is app and test. Now, the next thing is the spec, right? A spec about the replica set itself. The next thing is the replica. So here I will mention how many instances of my Redis image should run. So let's say 2. The next important is the selector, right? So here in the selector, I have a section match labels. The match labels should be same whatever is there on the pod, right? So let's say app test I have given over here. Okay. The next is template. This is very important. In this we specify match labels and then the template, right? Everything is correct, right? Selected match labels, app test, everything is fine till now. Under the template, we specify the pod definition. Again, about the pod definition, first thing is metadata. What is the name of my pod? So my pod name is, let's say, Redis pod. Okay, that's it. Labels on my pod. The labels again need to be same, whatever you have specified on the replica set. Match label section, right? This one, app test. That's it, done. The next important thing is a spec, a specification about your pod. So the very first is containers. So containers is type of list, but I only have single container running inside my pod, and that's name is, let's say, Redis container. And what the image it will use? Images Redis. It will by default use the latest. Okay. Here there is some space. Okay. And this need to be parallel. That's it. So let's try to create it. If there is some issue, we will get to know. So here we got this error. Let's try to fix it. Open this particular file. I think this replica set S should be caps. Let's try to create now. Yeah, it is created, right? Now kubectl get rs. Desired is 2, current is 2, ready is 0 for now. Next, no pods are running now. See, here it is in the container creating state. Let's wait to be created. And now it is created, right? Now your Redis is running on these two particular pods. Let's try to delete one pod, right? So replica set will make sure that this particular pod is being recreated. It is deleted, right? So yes, 37 seconds ago, the pod is being recreated again. So this is the main purpose of your replica set. Okay. I hope now you're clear with the concept of the replica set because you already saw, right? Once I deleted this particular pod, automatically the pod is being recreated, and that is the job of the replica set itself. It is trying to recreate your pod. So you don't need to worry about this part, anything, right? So this is the main purpose overall of the replica set. I hope now you're clear. If you have any doubts, do let me know in the comment section. In the next lecture, I will discuss about the deployments and slowly we'll go into deep of all these concepts. Okay. Thank you so much for watching our videos. Thank you.